Hello everyone, myself Rahul. So today I'm going to solve a problem called Subarray Sum Equals K. So the problem is something like this. We are given an array of integer nums and an integer k. We have to return the total number of subarrays whose sum equals to k. A subarray is a contiguous non-empty sequence of elements within an array. Right, so we are given an array of integer nums and we are given an integer k as well. So we have to return the total number of subarrays whose sum is equal to the k. Right, so in this problem 1, 1, 1 and k is equal to 2. So what are the possible number of subarrays? So we can consider these two ones, and yeah, like first these two ones can be considered and then I can consider these two ones to form the sum equal to 2. Right, so I cannot consider this one and this one because these are not contiguous elements. So the output is 2, which means that we have two possible solutions to this. Similarly 1, 2 and 3. So what are the possible ways in which I can form a sum of 3? So the first way is 1 and 2 can be considered, and the second way is we can just consider this 3. Right, so we have to return 2. So let me try to explain this problem once. So suppose we are given any array, right? So the first thing is we have to keep in mind that the subarray has to be contiguous. By contiguous we mean that all the elements has to be present adjacent to each other, right? So this is one contiguous subarray, this is also one contiguous subarray, this is one. Like it shouldn't be that we are taking first few elements from here and there is some gap and then we are taking the rest of the elements, right? So we have to find the number of subarrays whose sum is equal to k, right? So it's a very simple problem. The brute force method for this approach would be like if we just try to find out what are the possible subarrays in this given problem and compute the sum for those all possible subarrays, and then we can check for those subarrays if the sum is equal to k. So how can we generate all the possible subarrays for a given array? So the answer is simple. We can just write two for loops. So for loop can start something like this, like I is equal to 0 and I is less than n, and the inner loop in which we can have a variable j which is starting from I and j is less than n, right? So in this loop we can keep on computing what is the sum I have, array of j, and if at any point sum is equal to k, then I can return the basically increment the count that I have a particular subarray of sum k, right? So inside this I can increment my count variable, right? So how is this algorithm going to work? So let me just quickly give you how it is going to work. So suppose this is the array, right? This is the array. So the outer loop is something like from where we are going to start this subarray. So we are going to start this subarray from over here, suppose the starting index. So the inner loop is going to work like this. So we are going to compute of these two elements, then keeping the first element as fixed, that is I, we are going to increment j. We keep on doing this, right? So this is one outer loop iteration. When I increment I, so I moves over here, so I don't need to consider the first element. So I will be doing something like this, right? So all pairs would be generated, not all pairs, all subarrays would be generated. So I'm creating all possible subarrays and computing the sum for those, right? So the complexity for this would be, time complexity would be O of n square. I'm not using extra space, or space complexity would be O of 1 only, right? So what is the better way to do this? So if you observe this problem carefully, right, so if we are suppose given this array, suppose this is the given array, right? I need to find a subarray. In short, I need to find if there exists a subarray whose sum is equal to k. So suppose this is a subarray whose sum is equal to k, and this is suppose the ith index, right? And I have reached this ith index while iteration, and somehow I am also maintaining what is the sum I have encountered from the beginning of the array. So whenever I am doing next iteration, like I am moving one step ahead, I am incrementing this sum variable with whatever the value present at the ith index, So sum is nothing but sum plus array of I. Right, so if this is some value, this is the k value that I need to find. So what is this remaining value? It is nothing but sum minus k. So somehow if I maintain that whether I have a sub array starting from the beginning of the array with sum as sum minus k. So suppose I have some hash table or some set or map kind of thing which is telling me whether sum minus k is existent in that particular data structure or not. So this, suppose I have a data structure in which I am maintaining what is the possible sum, like what is the sum present till the ith index, right? So somehow in that data structure, if I'm able to find sum minus k value, it means this value is existent. So there has to be one subarray with k as the sum, right? So there will be one subarray ending at the ith index with sum as k, right? So that data structure is nothing but in our case is unordered map. So what I am will be doing is the unordered map will have key value pair, the key and pair. So key denotes the sum present between 0 to a particular index, 0 to any index, and this value will denote how many times that sum has occurred, the count of that sum, right? So suppose this is the given array, right? I'm not taking the values for the sake of convenience. So suppose from here to here the sum is 5. So in this map I'm going to insert 5 comma 1, right? And suppose from here to here the sum is 10. So in this map I'm going to update it with 10 comma 1. 10 because the sum from the beginning of the array is 10 till this particular point. So it is 10 comma 1. 1 denotes that I have encountered this sum of 10 one number of times. Now if I suppose go one step ahead till this point, suppose the sum is again 5. So as you can see, like the sum can decrease as well because it's an array of integers, not positive integers. So there may be some negative integers present over here, due to which the sum has decreased from 10 to 5. So I will see that 5 is already present inside my map. So I will update this count from 5 1 to 5 comma 2, right? Now if I reach a further index, suppose here the sum is 15 and k value was suppose 10, right? Like I have to make a sum of 10. Then what I need to do over here is so till this point the sum is 15 and my k value is 10. So what I have to do is I need to check whether 15 minus 10, this value is 5, this 5 is present in the map or not. I will see that 5 is present in the map, and what is the value for corresponding to that? It is 2, which means 5 is present 2 number of times, which means there are 2 possible sub arrays at this particular index, because till here the sum is 15, right? So one sub array would be nothing but this sub array, yeah. So one sub array would be this sub array and the other sub array would be till this sub array, like from here to here, right? From here to here. One sub array is this and the other sub array is from here to here, because till this point the sum was also 5 and till this point the sum was also 5, right? So this part has sum of 5 and 10, and this part also has a sum of 10, right? I will try to code this problem quickly. Yeah, so here I have to do over here is I need to create one unordered map of int and int. Let's call it mp, and create one variable called I and count value suppose as 0, which is going to tell me what is the count number of subarrays I have encountered till now with sum as k, and initialize a variable called sum, which is going to hold values of the sum of all array elements till a particular index. So I is equal to 0, I is less than nums dot size, and here I am going to check if here sums can be updated as sums plus, not sums, it is sum plus nums of I. So here I have to check whether mp dot find of sum minus k is not equal to mp dot end, right? So because mp dot find sum minus k, so I am checking like till this point the sum value was 15, right? One sec. So till this point the sum value was 15 and k value was 10. So I am checking 15 minus 10, which is 5, whether 5 is present in the map or not, right? So if I am not able to find it, if it is not equal to mp dot, if I am able to find it, it means it is present in the map. So I am going to update my count value as count equal to count plus whatever the value is there for sum minus k, mp of sum minus k, right? And the other check I need to do is if mp dot find sum is not equal to mp dot end, then I need to update that value, right? Because 5 was supposed already present inside this map. This 5 was already present inside this map with 5,1 as the value. Then I again encountered this 5, so I need to update my map from 5,1 to 5,2, right? So that's what I have done over here. If I am not able to reach to the end of the map for the value key as sum, then I am going to update this the value for this particular key. The key is sum. If this is not the case, like this is the first time I am encountering the sum, then I need to mp of sum is equal to 1. Like it's just nothing but a frequency of that particular key, right? Here I can return count. One more thing I have to do is for the sum value is 0, the count value will be 1, right? I'm running this code. I hope there are no compilation issues. Okay, comma has to be there. Yeah, submitting it. Yeah, runtime memory usage fine. What is the time complexity for this? So time complexity is nothing but of n only, as we are iterating over this array only once, and the lookup for inside this map would be O1 in the on an average case, and the space complexity is also of n. And so time and space complexity is of n, but the brute force method was giving us a time complexity of O n square, but the space complexity of O was O1 in that case. So we have improved upon time complexity, but on the cost of space complexity. So yeah, that should be fine. I hope the solution is clear, and if you have any comments or suggestions to this solution, I will see you in the comment section. So take care. Thank you everyone.